This video is going to cover some partial fraction decomposition. So what you need to do is you're starting with a rational function, a polynomial divided by a polynomial. If you can, you're going to factor the denominator completely. In this case, both of these are prime. We cannot do that. So we're going to create separate fractions. Remember, for a linear factor, it's just the letter divided by the factor. So in this case, a divided by x plus 3. For a quadratic factor, x squared plus 5. The quadratic term is inside the parentheses. We need a linear numerator, so bx plus c divided by that x squared plus 5. All right, now what we're going to do is we're going to solve this equation. So we're going to multiply through by this denominator of x minus 3, x squared plus 5, which is your least common denominator. So what's going to happen here is both of these factors will simplify to 0. So you're just going to be left with the numerator, which you see here. Here, the x minus 3 and the x minus 3 will simplify, and you're going to be left with the x squared plus 5. And here, the x squared plus 5 and the x squared plus 5 are going to simplify to 0, and you're going to be left with x minus 3. Your goal is to be able to, so you have 3 unknowns. You don't know what a, b, or c equal. Your goal is to get rid of 2 out of the 3. So if we can make this whole thing equal 0, b and c are going to be gone. So to do that, we take this x minus 3. Think about what value would make that 0. X equals 3. So what you're going to do is substitute in 3 on the left side for x and the right side. So here you're going to get 3 squared is 9 plus 5. That's where the 14 comes from. 3 minus 3 is 0, so 0 times anything is 0, so this whole thing zeroes out. So you get a is negative 7. Now we know what a is. We just need to get rid of b or c, make one of those 0. So what we're going to utilize is making b equal 0. I'm sorry, not making b, but making x equal 0, because then b times 0 is 0, and we're also going to substitute in the value of a. So this will allow us to find c. So if x is 0, this whole thing is just negative 56. The a value is negative 7 times the 5. Here, b times 0 is 0. C times negative 3 is negative 3c. Add the 35 over, divide, you're going to get c is positive 7. So at this point, we know a and c. We just need to figure out the value for b. So we're going to use what we know. We know a and c, and we just need to pick a simple number for x that we have not used already. We've already used 0. That would be the simplest, so we're just going to go to 1. So you're going to plug 1 in for all the x's. So same thing next to the a, you plug that in for the x's. Same thing here. C is 7. Here, 1 minus 3 is negative 2. Here, you just got to be careful. You got to remember you're distributing. B times negative 2 is negative 2b. And then 7 times negative 2 is negative 14. So that's where this is coming from. We added the 42 over to get that, and then you're just doing some simple algebra to get b equals 3. That is not your answer. You have to write the fraction into these separate fractions. And oops, let's take a look at that. Let me scroll down a little more. Perfect. So what you have, you're just substituting in your value for a. A was negative 7. So you see that there, negative 7. B was 3. And c was 7, and you see that in that numerator there. So this represents your answer. Those are the separate fractions. All right, that's partial fraction decomposition. That is Unit 5, Topic 2.